Viewers, welcome to this video. Today I want us to look at reflection and the transformation. Reflection and the transformation. Now, viewers, look on the board. When you have something like, when you have the XY plane like this, this is the x-axis, this is the y-axis. So the x-axis is also the same as, or it's also called line y equal to 0. And then the y-axis is also called line x equal to 0. So let's assume that this is 0, 1, 2, 3. 1, 2, 3, negative 1, negative 2, negative 3. That's negative 1, negative 2, negative 3. When you have the xy plane like this, reflection, you are looking at reflection. If you have a point here, say 1, 1, are you seeing it? This point, you can call it, say, A, 1, 1. When this point is reflected in the x-axis, they assume that this is a mirror. So if this point 1, 1 is reflected in the x-axis, this is a mirror. So the image will be found here. So the image will be, let me say, A1, and it will be 1, negative 1. Are you seeing it? Yes. So we have what we call reflection in the x-axis, or line y equal to 0. Y equal to 0 because this line, on this, when you have this line, the value of y is 0 as far as this line is concerned. Look at it. Because this is 1, this is 0, negative 1. So this line is y equal to 0. And then if it is y-axis, then this line is x equal to 0. It's cutting the x-axis at 0. Are you seeing it? That's why you see this is x-axis, or line y equal to 0. Or, yes, and then when you come here, y-axis, or line x equal to 0. So reflection in the x-axis, when you have 1, 1, you are going to get 1, negative 1. So what is this telling you? This is telling us that if you have, this is the x coordinate, and this is the y coordinate. And so this is the x coordinate, this is the y coordinate. So what is happening? You can see that the x coordinate has not changed, but the y coordinate has changed. Do you see it? So it means that 1, reflection in the x-axis, or line y equal to 0. You can say that when you have xy, it should map onto x negative y. Yes, because 1 didn't change, and the x coordinate didn't change, but the y coordinate has changed. Yeah. So that's why. So when you have say 1, 1, then it's going to give you 1, negative 1. Are you seeing it? So for reflection in the x-axis, the x coordinate does not change, but the y coordinate changes. So if you have another one like this, maybe 2, negative 2, or 2, negative 3, when you have something like this, you are seeing that the x coordinate does not change, but the y coordinate changes. So negative 3 will change and to become what? 3. If you have something like this, maybe negative 4, 2. If you have a point negative 4, 2, when it is reflected in the x-axis, then you are going to have negative 4, negative 2, because the point is that the x coordinate does not change, but the y coordinate changes. Are you saying? So look at the formula. The x coordinate does not change, but the y coordinate changes. And finally, when you have, say, negative 2, 0, when this is reflected in the x-axis, or line y equal to 0, then you are going to have, still going to have something like this, negative 2, 0. Yes. So these will be the images of these points when reflected in the x-axis. So this is the first type, reflection in the x-axis. Now, let's look at the next type, reflection in the y-axis. Reflection in the y-axis. Reflection in the y-axis. Or line x equal to 0. Yes, at times they will not say y-axis, they will just say reflection in the line x equal to 0. So you have to know that they are talking about the y-axis. Now, let's use this same point, reflection in the y-axis. So this point 1, 1. Because we are talking about the y-axis, it means that the mirror is this. This is the mirror. So if you are standing here and there is a mirror here, your image will be found here. Yes, so the image, let's call it A1. And then this image is negative 1, 1. Negative 1 on the x-axis and then 1 on the y-axis. Negative 1, 1. So what is this telling us? So this is x, this is y. This is x, this is y. So for reflection in the y-axis, you can see that the x-coordinate has changed, but the y-coordinate has not changed. So you can just see that for reflection in the y-axis, this is 2. xy maps onto negative xy. Isn't it? Because it's a reflection in the y-axis. So the x-coordinate will change, the y-coordinate will not change. Yes. So that's why when you have 1, 1, it has become negative 1, 1. Isn't it? So if you have say negative 1, negative 7. This one, we are saying that the x-coordinate should change, but the y-coordinate should remain the same. So negative 7 here, and then this one will change to positive. If you have, say, 1, negative 1, 4. Well, let me just say, yes, 1, 4. Then this one will be negative 1, 4. Isn't it? And lastly, if you have, say, 0, negative 3, then this one will be 0, negative 3, because you are saying that the x-coordinate should change, but it cannot change 0. So the objects and the image will be the same. So these are the images. This will be the images of these points when reflected in the y-axis or line x equal to 0. Yes, so this is the line x equal to 0 on the y-axis, and this is the line y equal to 0 on the x-axis. Now let's look at the next one. You also have the third type of reflection. Yes, the third type. The third type. 3. Reflection in the line y equal to x, or you don't want to confuse you, you can say or y minus x equal to 0. Yes, let me explain this. So y equal to x. Now when you have y minus x equal to 0, if you make y the subject, yes, I have a video on change your subject. Those of you who don't understand change your subject, you can go and watch that video. If you make y the subject, y is equal to what? X. This one will go to the other side. So at times, instead of giving you it to you straight away this way, they can write it this way to confuse you. So when you see this way, the same as y equal to x. Now, this is the line y equal to x, and this line, yes, this is the line y equal to x. What this means is that if you pick any point on this line, the x value and the y value are the same. Yes, they are the same. If you pick any point on this, so this is the line y equal to x. Now, so what this means is that xy should map onto, look on the board, we are saying y is equal to x. So to write the formula, you can just say y, you are equal to what? X. Y, you are equal to x. X, you are also equal to y. So for reflection in the line y equal to x, or y minus x equal to 0, we just interchange in the coordinates. The x coordinate to become the y coordinate, and the y coordinate to become the x coordinate. For example, when you have something like this, maybe -1, 2. Then straight away, this one will be 2, -1. You just interchange the values. When you have a point, when you have something like this, 4, -3, then this one will straight away become -3, 4. Are you seeing it? Yes. So this is a reflection in the line y equal to x. Y equal to x. Okay. Now let's look at the fourth type. The fourth type. We have reflection in the line y equal to -x, or y plus x is equal to 0. Yes. Because look at what is happening. Y plus x is equal to 0. You want to make y the subject, then y is equal to this one, go to the other side and become negative. So it's the same as this one. So reflection in the line y equal to -x is the same as reflection in the line y plus x equal to 0. So you take note of this. Yes. Now, this is the line y equal to -x. This is the line, this line. Y equal to -x. Yes. Y equal to -x. So what this means is that when you pick any point on this line, the x coordinate is the negative of the y coordinate, and the y coordinate is also the negative of the x coordinate. Are you seeing it? So that's what it means. So let's try to get a formula. Say xy maps onto, look at what is happening. Y is equal to -x. So I just come here and say y, you are equal to -x. You see it? Now, if you have y equal to -x and you want x, you can divide here by -1, here by -1. So x will be equal to -y. Are you seeing it? So x, you are equal to -y. So what this means is that to reflect a point in the line y equal to -x, you interchange their values and negate them. Yes, you interchange their values and negate them. So when you have something like this, say 1, 2, being reflected in the line y equal to -x, then it's going to be, you see, first of all, interchange them, so 2, 1, and they are saying you should negate them, so negative. Are you seeing it? So when you have a point 1, 2, and it's reflected in the line y equal to -x, or y plus x equal to 0, you are going to have -2, -1. Do you see it? And then the next one, if you have say -4, 3, and this is reflected in the line y equal to -x. Look on the board. You see, you have to interchange their values. So 3 will come here, -4 will come here. And they are saying, after interchanging their values, negate them. When you negate this one, it will be 4. When you negate this one, it will be -3. Let's look at the last one. Let's assume that you have, say, -7, 0. -7, 0. When you have something like this, they are saying, first of all, interchange them. So 0 will come here, -7 will come here. They are saying that after interchanging them, negate them. So when you negate, this one will go. 0 cannot be negated, so it's still 0. So this will be the image of this point when it is reflected in the line y equal to -x, or y plus x equal to 0. So these are the images of these points. Yes, when they are reflected in the line y equal to -x. So this is the fourth type. Yes, this is the fourth type. This is the fourth type. Now, let's quickly look at the fifth and the sixth type and bring this lecture to an end. So you also have reflection in the line y x equal to k. X equal to k, where k is a constant. Where k is a constant. Where k is a constant. In fact, I'm trying to give you the simplest explanations you can ever get. Yes. So after this lecture, reflections should not be a problem to you at all. Now, reflection in the line x equal to k, where k is a constant. So you can have reflection in the line x equal to 2, reflection in the line x equal to 3. When you say reflection in the line x equal to 2, it means that k is what? Equal to 2. So reflection in the line x equal to 3, it means that k is 3. Now, this one too, at times if they want to confuse you, they can say reflection in the line S minus K equal to 0. Are you seeing it? So we have to be very, very careful. Now, this is the formula. Reflection in the line S equal to K. You have XY mapped onto, because we are talking about reflection in the line S equal to K, Y will remain Y. Then this one will be 2K minus S. Yes, this is the formula. Where then this K is a constant. This K is a constant. So let's try to look at examples. You can say find the image of the point. Let me say A 2, 4. When it is reflected in the line, S equal to say 3. Yes, there is a point, and this point is being reflected in the line S equal to 3. Yes, so we want to find this image. So straight away, we have to use the formula. So if you are using the formula, this is the formula. So it's going to be 2, 4. It's now going to give us what? 2. Look at the formula. Times K. Because the reflection in the line S equal to 3, K is equal to 3. So 3 minus X. And the X value is 2. Are you seeing it? And the Y value, according to the formula, should not be changed. So it is 4. So this is equal to 2 times 3 is 6 minus 2, 4. 4, 4. So finally, this point will have image maybe A1 this way to be 4, 4. So the image of this point, when it's reflected in the line S equal to 3, is 4, 4. It's not difficult at all. So when they say S equal to negative 5, it means that the K is negative 5, and then just use it. And then the formula will follow. Yes, so it's not difficult at all. Now, let's quickly look at this one is 5. Yes, let's quickly look at the last one, the 6th one. Reflection in the line Y equal to K. Yes, these are the main types. Reflection in the line Y equal to K, where K is a constant. And this one, you can also see reflection in the line Y minus K equal to 0. Yes. So let's look at it. Now, because it's a reflection in the line Y equal to K, you have XY, the formula is this. Mapped onto, it's a reflection in the line Y equal to K. Yes. They are not mentioning this name to X. You have to remain unchanged. And then this one is 2K minus Y. You have to take note of this. So, for example, let's look at an example. We can give you an object. You can say find the image of the point maybe negative 2, 4 under a reflection in the line 5 is equal to 0. Yes, look at how I've written the question. Now Y plus 5 equal to 0 is the same as, so when you are solving it, this one is the same as Y is equal to what? Negative 5. So it means that K is negative 5. Yes. So if you are using the formula, then I'm going to have negative 2, 4. We'll have this image. According to the formula, S should remain unchanged. So negative 2, I should just maintain you. I should not touch you. And then 2 times K. You see it? And K is negative 5 minus Y, which is 4. So this one will give us negative 2. 2 times negative 5 is negative 10 minus 4. Negative 14. So it means that the image of this point, when it is reflected in the line Y plus 5 equal to 0 or Y equal to negative 5, is B1. Let's assume its name is B1 minus 2 minus 14. Yes, so when you ask to plot it, just plot it. Yes. So viewers, these are the main types of reflection. And if you have really understood this, you should be able to solve any question on reflection and the transformation. Thank you very much for your attention. For more of this video, subscribe to my YouTube channel, Shamalaa Jnr. Thank you very much.